Now, one other interesting thing that DuckDB has that really differentiates it from, say, SQLite or Postgres is it has really interesting integration with Python. Now, this is a little bit piecemeal, and so some of the examples might indicate that the integration is a bit deeper than you might think, but let me show you what we can do with DuckDB. We can select from NumPy and arrays. So this select operation hasn't done anything explicitly to put this NumPy and array into DuckDB. I haven't had to do a create table. I haven't had to do an insert operation. I can just select from a name, and DuckDB will search through the local namespace and identify, oh, that's a NumPy and array. Let me go look through that. I can select directly from a pandas data frame. It is somewhat unfortunate if I try to select from other things. For example, if I try to select from a Python list, that doesn't quite work, even though I can select from a NumPy and array. And you can see I'm quite limited in what I can select from. A pandas data frame, I can't even select from a pandas series. I would anticipate that that's something that would get fixed at some point in time, because why you can select from a data frame but not a series, I don't get. Other than there are some indications when you look at the DuckDB integration with Python that the DuckDB authors didn't quite have a very complete understanding of pandas, because there's a lot of places where they ignore details of how we should be using pandas and instead focus on how people actually do use pandas. So a lot of index avoidance. Well, setting that aside, it's still pretty impressive that we can select from a data frame or select from a NumPy and array. And it does bode well, because that means that potentially if we have some small, narrow code and we have some belief that DuckDB can perform an operation on that code faster than we can perform in pandas, for example, the group-weighted summary statistics, well, we might have an easy way to just quickly drop down to that analytical layer and perform that operation more quickly. Additionally, if we're using an arrow-backed pandas data frame, you may hope or imagine that we might have an easy way to share data between the DuckDB layer, our pandas layer, and the underlying data storage as well. This is what Arrow is built for. And of course, I can't quite speak to the specifics of how well that works, but we do have a session coming up talking about Arrow, and that may be something that we discuss there. I can also do some things which kind of look like I'm working from pandas data, from pure Python, like select from a range, which is not really SQL. Here, this is just it's trying to mimic a Python range object, but it's not exactly a Python range object. And it's not exactly the case that any arbitrary iteration helper works, because you can see here something like enumerate doesn't work, zip doesn't work, and things like that. That's one thing that I think would be very interesting to add to DuckDB, the ability to support some simple iteration helpers so that, for example, if we had an x and a y value, we could select from the zip of x and y, something like this, without having to first constitute a pandas data frame and then do that. Because the pandas data frame, you can imagine, might do an implicit copy, even if we get all of the flags of creating that data frame right. We're never quite certain what that data frame does. There's some other extended syntax here, like you can sample tables. Generate series, you can see, is very Postgres inspired. And in fact, a lot of DuckDB functionality is very Postgres inspired. We can also select directly from a file name. So here you can see I can select directly from my data.csv. I don't have to do that second operation where I connect to this. And so you can imagine that if I wanted to use this for some very simple scripting where all the files are in CSV and I don't even want to have a Python script in the first place, I could write just an SQL file and perform operations directly on that CSV data. But do note that this integration is still not exactly perfect. It is the case that when we store the data in DuckDB, we are at lower fidelity than anything that we can store in Python, or even anything we can store in pandas. And so, for example, we have operations for loading a pandas data frame from a DuckDB data source. Here, we can use a fetch_df operation, but it is the case that we still need to set our indices. We still need to deal with data types that are not supported by DuckDB, like the categorical data type. We may still need to do some sorting. We may even still need to constitute a series object by squeezing on these values. And like with any other data storage format, pandas really just has a richer set of data types and a richer ability to represent columnar data, that is, with an index with both multi-indices on the rows and on the columns. And we may still need to do that reconstitution process when we're dealing with data from DuckDB. So it's not the case that we can just transfer data back and forth trivially. There may be some additional steps, and we still may need to write some loader and save wrapper layers. Do note that DuckDB has some other functionality, but in my initial investigation, I couldn't quite see where that would be useful. There is some functionality for expressing SQL expressions separate from their execution. So like a case expression that looks for all the places where the value is negative and performs something like a NumPy where. But ultimately, I don't know that constructing SQL expressions in this fashion is altogether that valuable. I've seen programmatic attempts to construct SQL before. Usually, they just lack the fidelity of SQL itself. And so my personal belief is if you want to construct SQL programmatically, what you really want to do is you want to extract the parser from your actual SQL engine, which has happened. You can get a C bindings for the Postgres parser by itself, actually construct the AST and perform AST level transformations, not some kind of half-implemented, hokey, pure Python type stuff. Otherwise, I don't think there's anything wrong with this. I'm sure that there are circumstances where somebody might use it, but I don't really see the compelling use case there. And so with that, we can see what DuckDB provides us. And hopefully we have an answer for a question of, is this tool worth looking into at all? And I would say with a resounding yes, it is worth looking into DuckDB for your tail end analytical uses. In cases where the data set has already been collected and already exists in memory or on disk, DuckDB may be able to provide you with analytical tools to perform that data analysis faster than you might be able to do easily in Pandas or on data sets larger than what you do in Pandas at some loss of generality. Whether or not you should charge in and replace all of your analyses, especially if you're using Pandas, especially if you're using a lot of the features of Pandas, like index alignment with something like DuckDB, that remains to be seen. Because I suspect that it will require a significant amount of rewriting of your code, and there may definitely be cases where you just hit a brick wall, and just like in Pandas where you ask yourself, can I do this efficiently? You may find yourself asking yourself in DuckDB, can I do this at all in SQL? And so I would say that at least in the most narrow use cases where you can affirmatively decide, DuckDB has the ability to support the analyses that I want, group-weighted summary statistics, if that's what it happens to be, or other types of statistical operations, and the data is not growing, it already exists in one place, and the data is maybe even nearing the maximum what you can store in Pandas, well, definitely DuckDB is worth looking into. Thank you all for joining us for this session, and I hope that you have been exposed to a new tool that you may be able to use to empower your work. That's the point of these sessions, for us to say, are these tools worth the hype or not? And hopefully to identify tools where there's something beyond all of the hype, there's something worth looking into, as is the case with DuckDB. Thank you all for joining us, and I encourage you to join us for our upcoming sessions on Polars, another Pandas competitor, as well as Arrow, a tool that we might see as not competitive with tools like Pandas or Polars or DuckDB, but instead is competitive with some traditional ways in which we might store our underlying data in formats like CSV, or backends for tools like Pandas, that is the NumPy backend. I hope you'll join us for those sessions, and I hope they'll provide you with additional feedback and additional guidance for new tools that might help accelerate your work. Thank you all for joining, and I'll see you all next time.